go the whole period. We're just going to march through chapter 14. And tomorrow I'm going to go about an hour, and I'll give you the last 20 minutes of class. The lab is due on Thursday, and the accepted value for the concentration of the HCl solution was 0.11. So you should note that, the accepted value. And remember how you do percent error. The percent error is equal to the accepted value, which I just gave you, minus the experimental value, which you should have determined, over the accepted value, and you multiply by 100. And sometimes it comes out to be negative, and if it's negative, just take the absolute value. Okay, so that's this week. So, and then I'm hoping, and I'm just going to ask you guys right now, well, this is a democracy. We live in a democracy. Next week, I think, is a testing week. Am I right?
Yes.
And I think that on Monday, it is an odd day. So it's like a Wednesday or a Friday, so we won't have class. But then I think on Tuesday, you have testing in the morning, and then we have period 2, our class, in the afternoon. That's the only time we meet next week, I think. Am I right, Jackson? And then on Wednesday, testing in the morning, and then period 4. And then on Thursday, testing in the morning, and then period 6. And then Friday, I think there's no school. I think, actually, not this weekend, but next you're off. Am I right on this, Kyle? Do you know? You're not here next week, right?
Yeah.
Next week. I'm pretty sure you have off Monday and Friday, and then Monday, which means you have a 4-day weekend, I think, in there. All that being said, okay, you guys tell me, okay, we're going to be done with 14 probably maybe by the end of tomorrow, and if not, by Thursday. We can test on a week from Tuesday, which is, again, that day that you guys will test in the morning, and I don't even know, PSAT, SAT. Or we could do this. We could move into 16, and we could test the following week on Tuesday. Does that make sense? So next week, so this week's a normal week, okay? So this week, like I said, the thing you've got to do is you've got the lab on Thursday. And other than that, it's a normal week. You need to get test corrections done, and if you wanted to bring in the Kleenex, you can. We're gonna do some good problems this morning, and then tomorrow we're gonna be close to done with 14, and then I think Thursday we'll get done, which means we could do review on Thursday when we're done, and then we could take the test next Tuesday, a week from tomorrow. So that would be April, let's see, today's the 5th, the 13th, okay? Or we could start on that day. And again, on that day, Allie, you have testing in the morning. We meet in the afternoon, which means if you needed extra time, which you might, we'd be done with school because our class will be like a normal block day, like period 6 is tomorrow, okay? Or on that day, a week from tomorrow, we could start chapter 16. We're going to just skip 15, and we will test the following Tuesday, which would be the 20th. Does that make sense to you? What do you want? Who wants it a week from tomorrow? Who would rather wait a week? Man, this is pretty close. Do you care, David?
The juniors have the SAT next Tuesday, so I want to do like the SAT and then a Chem test.
So you would rather wait, huh? Tell you what, I'm going to do a vote. Let's do this. So, I'm going to do the same thing in Liza's class. You have a preference?
I don't want to take it after the SAT.
So you don't. So, okay. So Sam and Liza probably bring up a good point. With knowing that juniors, you guys have the SAT next Tuesday morning, which, hey, that's a big test, right? Seniors can tell you that now. Of course, I don't know if colleges are, if the SAT is as big a deal as it used to be. So with that being the case, I just want to do numbers. So how about Tuesday, the 13th versus Tuesday, the 20th? Okay, let's do it. Who would want it a week from Tuesday? I'm going to count. We live in a democracy. 1, 2, 3, 4, 5. 5, okay. How many want it 2 weeks from tomorrow? 1, 2, 3, 4, 5, 6, 7. And I'll vote in your class.
Yeah.
7? Okay. And so what I'll do is I'll talk to Liza's class, and then we'll make a decision based on that. So Samantha, that's certainly a good idea. Okay, any questions on what's going on? Okay, so back to the where we were, and today we're going to do some good problems. Today would be a really good idea to have your calculators out. Yeah, I think I do. There was one left in here. Was this yours, Allie?
Yeah. Thank you. I keep forgetting about that. Thank you.
Tyler, I'm hoping the notes are coming up. Did the notes come up, Tyler?
Yeah, I can see them.
Good. Okay, so here we go into some good problems. What we did, real quick to review, we did a problem, this problem here, which is a legitimate problem. I'm calculating the pH of a strong acid. And a key thing in doing these problems is always going to be to write out the reaction. And I'm going to write out, the way I'm going to teach you, acids, like I said, you can include water or not. I'm going to do it without water. So the way I'm going to do these problems in writing equations, the only time I'm going to include water is when I have a weak base. Technically, the only time you don't need water is with a strong base. But we did this problem and then this problem, and I did it with writing the equation and doing an ice table. I'm going to do a whole bunch of those today. And then I did this problem, which was kind of almost a trick problem. So we did that. So to me, strong acid, strong base problems are easier. And then we went through this. So here is our, again, going through some good problems today. And Tyler, again, if there's something you can't see or there's something you can't see or hear or on the board, please just speak up, okay?
Okay.
So calculate the pH. So remember pH, this is on our formula sheet, is the negative log of the H plus. Probably too, I was looking, guys, I told you I really want to do a test on 14. We will do that. Okay.
Could you show the computer a little bit right?
A little bit to the right?
Yeah.
Like this, Tyler?
Yep, like that.
Okay. But in terms of, and I do want to try and cover at least the main ideas in chapters 16 and 17. I don't know if we're going to get to a test on 16, 17. We'll just have to see. We will do a quiz on both of those chapters. And remember, right now, I've got the Princeton review is due 3 weeks from today. So again, that still seems like some time, and especially with a 4-day weekend coming up. But that is something to get on to. But I don't know. We'll see if we can get to the place. The week of the AP test is we're just doing mock test. Okay, and that's Saturday, May 1st. And I told you this, Saturday, May 1st, from noon to 3:30, I'm going to be here. So, and again, I know some of you are doing track and some of you are doing baseball and you might have something going on that day. But if you can put it down, and I'm also going to be available. And I might come in that Friday, April 30th, which is a day I'm normally not here. But just if you want to come in and work a mock test, and then Wednesday, May 5th, I'll be here too, because you're going to have to find some extra time to do mock test. Alan?
I know you've already gone over this before, I think last week, but there's like 3 tests.
So this you're talking about the mock test?
Yeah.
So there's going to be 2 required.
Okay.
And one of them will have class time to do.
Okay.
And the 2 that are required is one you can do with your friends, and if you want to work with a group of 2 or 3 or 4 or 5 other people, fine. Have your book, have your notes. I'm going to make you grade all of them. The second one is one that you've got to do as much like the test as you can, which means we're going to try and time it. You're going to be on your own. You're going to use the resources that they give you. We're going to grade those. I'll combine those two, and that'll be your technical final grade. The third one, and you can either do just the free response or the multiple choice or both. I'll give you 10 for each part, will be extra credit. But again, understand that even in a normal year, we always get crunched at the end. And this year, I'm definitely setting aside that. It's Friday, May 7th is our AP test. That whole week is going to be time for mock test. So that's why we just might run out of time and not have time for 16, 17 tests. But I want to try and at least cover the main things. Does that answer your question?
Yeah.
Juliana, did you?
So the mock test will kind of be your final.
That'll be technically your final. Now, juniors, you're a senior, right? Juniors, and everybody, Dr. Page wants us to do this, and it's probably a good idea, is we're going to come back and we're going to do a day or two on nuclear chemistry and a day or two on organic chemistry. And when we have our actual final, and those are things that if you take chemistry beyond our class, you'll have, and especially nuclear chem. And then if you go down the science field, you'll take a whole year of organic chem. So in a period or two, we'll at least give you the groundwork. Juniors, what we'll do on the actual day of the actual final, after seniors have graduated and are gone, we will have a test, but it'll be a test. I'll let you use your notes, and I'll let you use your book. It'll be 50 points. It'll be way easier than any test you've had this year. Okay, that's the juniors. Seniors, you'll be gone by then. You'll have your diploma, I think. And when is graduation? What's the date?
So for seniors, all we have left is the test.
You have a test on 14 for sure. You have the mock test, and if we have time to do a test on 16, 17, we will. But I'm thinking, Juliana, we probably will not.
So we kind of just have 2 more test grades left. And the
Right.
Princeton review.
Right, and the Princeton Review, which will be a test grade. Good. Any other questions on that stuff? Okay, so here, so what I'm going to do first, and again, Tyler, if there's something you can't see, please speak up like you just did. I'm going to write out the equation, and again, I'm going to do this, and this will work on our test. This will work on the AP test. With an acid, you can show it ionizing, dissociating without water on any acid. And then I'm going to do an ice table. This is going to go back to something that we talked about in chapter 13. And so our initial amount here, we're trying to find the pH. So if we can find the H plus, we can find the pH. And so it says that it is 0.1 molarity here. Now remember, in an ice table, on this side, we have 0. Okay, so we have our initial amount and 0. Now when it was a strong acid, what we started with, we subtracted, it was all gone. But when it's a weak acid, it's not like that. So here I go minus X, and then plus X, plus X. And to me, always kind of that C row, the change is always kind of the key row here. Now, one thing I
Could you move it slightly to the left?
or in chapter 13 was if you take your initial concentration of a reactant or a product and you divide by the K value, if that number is 100 or around 100 or greater, you ignore X. Okay, so I'll say it again. So you take the concentration of the reactant and you divide by the K value. If that number is 100 or greater, you can ignore X, which is what we will always do. And this is a huge number. This time it's not even close. So the whole reason for that is ignoring the X of a value that you have. So I can ignore this X. So now I've got the Ka. And again, if I'm trying to find the pH, if I can find the H plus, I can find the pH. So what I've got here is I've got X times X over 0.100. So again, I'm going to ignore that X. That's what this tells me. Now, I'll have a way to check this at the end, which is that 5% rule, and I'll do that. And remember, at the end, if it's under 5%, then ignoring the X was okay.
So why can't we skip the X first?
Because Mason, the value for X is going to be so small that just the mathematical of the value is just, we can ignore it. And so the way you can always do this up front, and I'll tell you it's going to work in all the problems that I'm going to give you on the quiz and the test, because if I don't ignore it, then I have to use the quadratic equation, and we're not going to do that. Okay, so if I do the math here, the K value is 3.5 times 10 to the negative 8. X times X is X squared over 0.100. Okay, you should solve for X. And again, I know that this is for you guys a slam dunk. It's not a problem. But I think the process of doing it is a good thing. Allie?
So just real quick again, that like 3.5 it's that if that's greater than which number you can
If you take the concentration of the reactant divided by the K value, if this number is around 100 or greater, you can ignore the X if you have a value. And then at the end, I'm going to go back and I'm going to check it with the 5% rule, and I'll show you that. Okay, so if I solve for X here, what I get for X, I've got, I guess, 2 sig figs. So what I have is 5.9 times 10 to the negative 5. Did anybody else get that? We good? Okay, now to find the pH, I'll do the negative log of the H plus. So I'll do the negative log of 5.9 times 10 to the negative 5. Liza, you're going to get to hear the jokes twice today.
I cannot wait.
Poor
I'm so
Liza.
excited.
And so what I get is 4.23. Now remember too, when you do the pH or the POH, is that the sig figs start at the decimal. So if I want 2 sig figs at the decimal, 4.23. Okay, a couple other things at that see you, Liza, see you in a little bit. Does that answer make sense? This is a weak acid. So does a pH of 4.23 make sense? It does make sense, right? It's less than 7. And then the 5% rule, which is now at the end and ignoring this X. Okay, this is something we did in chapter 13. So I take the value that I have, 5.9 times 10 to the negative 5, divided by 0.1 times 100. And, Mason, you asked a really good question. Why do we ignore the X? Well, the value for X is so small compared to what we started with. What I get is 0.059%. So just if you think about it mathematically, so that means ignoring X was okay. So Mason, to answer your question, so if I put this here, so that's what I found X to be. So I'm just going to do it on my calculator. 0.1 minus 5.9 second exponent to the negative 5th. It doesn't hardly change the value at all.
Okay. So does that percentage have to be less than 0.05%? Like
When you do this, it needs to be 5% or less.
5%.
And what that is just telling you is making this assumption we can ignore X was an okay assumption. Okay, good. Questions there? Okay, look at this problem. I think I have one problem like this on your lab.
I don't think it's wrong. Maybe it's from like last year.
Oh.
And it wouldn't
That makes
surprise
sense.
me. It wouldn't surprise me.
My brother. I was not cheese.
Literally no.
Okay, so this is what we have here now is we have a mixture of acids. And what we're trying to do is to find the pH. So the pH, again, is going to be equal to the negative log of the H plus. So if you look at this, what if you have two or more acids or mix? What would you logically think? Which is going to determine the pH? The stronger acid or the weaker acid? Which one's going to produce more H plus? The stronger acid, right? So the stronger acid is going to determine the pH. Which of these two, and so I'm given the K values. This goes back to something we talked about last week. Which of these two then is the stronger acid? The HNO2, because its value for its K value is greater. And these exponents are always negative. So here's negative 10 for the HCN, and here's negative 4. So what determines what is more acidic, and I think there's, again, I have a question like this on the lab. What is more acidic is the one that has the higher K value. So that's going to determine the pH. So the one with the smaller K value is just going to produce a much lower amount of H plus. Okay, so I'm going to do kind of exactly the same thing. So I'm going to use the HNO2. So again, same process. So I'm going to write out the equation for the dissociating that acid. And again, I chose that acid because it's the stronger acid. It's going to produce a lot more H plus. So I'm going to write out the equation, and then I'm going to do an ice table. Do exactly the same thing I did before. So I have 5, 0, 0. Because it's a weak acid, it's not going to be all gone. And on the right side, I'm going to add, since it's 1 to 1 to 1, so I'll add X. Now, again, to make things easier, I'm going to do that rule I did it. We talked about chapter 13. I just did. I'm going to take my initial amount, 5, and I'm going to divide by the K value, which is 4.0 times 10 to the negative 4. And again, that number is going to be well above 100. Okay, it's 12,500, which all that tells me is that I can ignore this X. So the K value, Ka, which is, again, the K is the same thing we did in chapter 13, it's just A meaning it's an acid. So I've got X squared over 5, and it tells me that the K value is 4 times 10 to the negative 4. Okay, see if you can solve for the pH. Yeah, this is a good thing, that just good practice to go through the process on your calculator. So solve for X. So what I get for X here is 0.045. The negative log of that, I get 1.35. Anybody else get that? Does that make sense? Yeah, it's a weak acid, but 5 is a pretty high concentration, less than 7. Makes sense. And then if I check myself with the 5% rule, so if I take what I get, 0.045, divided by what I started with, times 100, just to make sure that assumption of ignoring X was okay. 0.045 divided by 5 times 100, 9.9%. So well below a 5%. Okay with that? Okay, then we're asked this question. the CN, determine the CN, the cyanide ion concentration. Okay, now we're going to go back to the weaker acid. Again, I've been looking at the test. I was actually looking at it about 30 minutes ago. Usually I throw a problem like something like this on the test. Okay, so again, I'm going to do the same process, but now I'm looking at the HCN. So I have, again, I'm going to write out the equation. You should always have a double arrow when it's a weak acid or weak base. So I'm going to write out the equation. I'm going to do an ice table. This one, and we're not trying to find the pH now. And we are told that this is 1, but now I know I have an H plus amount. Because I had H plus from the HNO2, it was 0.045. But I didn't have any cyanide. So then, again, I have minus X, plus X, plus X. And again, the good news from that monster awful quadratic that we did a couple weeks ago in chapter 13, but again, if I go back and I do this, where I take my initial concentration of both of those, either one do them individually, divided by the K value, 6.2 times 10 to the negative 10th, if that is around 100 or greater, ignore X, I'll be able to do that for both of these. So I have the Ka here, which is 6.2 times 10 to the negative 10. So then I'll have X, or I'm sorry, I'll have 0.045 times X over 1. So again, I ignore X. Okay, solve for X. Good.
So when you're doing the isotope for H plus, wouldn't it be 0.045 plus X, or would you?
It would have, yeah, it should have been. You're right.
So then, do you do that when you do the equation? Do you factor that in?
Well, this X, I'm going to ignore it though.
Okay.
In the end, but you're right. I did not write that out right. And so, Kara, if I did the same thing, if I took this divided by that, if that is 100 or greater, I ignore the X. So I do the same process. And if I did that, it's going to be a huge number because that negative 10 is a really, really small number. Okay. Good question. Okay, so what I get here, so what I get for the cyanide ion concentration is 1.4 times 10 to the negative. And I can tell the 5% rule. This number is so small. If I take that and divide it by either of those, it's going to be way less than 5%. Questions there? Okay, another thing, kind of same thing with that we're going to do that we've been doing, but it's called percent dissociation. Kind of like the 5% rule. Is how much do you get off? So the percent dissociation is exactly like the 5% rule. So you take what you solve for, how much H plus you get off, divided by your initial amount. So in doing A, so I've got acetic acid. Remember acetic acid, this H is part of the anion, it's part of the acetate ion, so it's not an additional H. So it's going to dissociate like this. So it's monoprotic. Again, I'm doing this over and over again this morning. I'm going to write out the equation, the chemical equation for the ionization or the dissociation. And then I'm gonna do, hey, Mr. Connors,
Hey, I'm sorry to interrupt, I need you to bail me out.
what's
I'm
up?
going over the answers for ideal gas laws and Dalton's laws,
Yeah,
and it's all on my computer is decided it's gonna reboot, and it's like 20 minutes into it.
well, here,
So do you have to have copies of the answers?
I do.
I apologize. But otherwise, I'm just sitting there for 20 minutes going, oh.
Well, let's do that. Okay, so in doing this, I'm gonna do exactly the same thing I did. So I start with 1. Again, 0, 0, minus x. Which, again, that x I can ignore. And again, if I check this up front, so if I take my initial amount, 1, divided by the k value, what I said, if this number is greater than 100, you can ignore the x. Well, this is going to be significantly greater than 100. It's 55,000, which is always good. And it can always be like this, but this is what we can do. So we can ignore x. Okay, so now if I solve for the x, so I'm going to do 1.8 times 10 to the negative 5th equals x squared over 1. Okay, solve for x. Again, just like I've said all year long, it's, I think, a really, really good exercise on your calculator to do this. Not that it's something that I'm sure all of you can do, but just to make sure that you can do this. So what I get is 0.0042. Now here, though, they didn't ask us the pH. If they had asked us the pH, I would have done the negative log of that. But they asked us the percent dissociation. So I'm going to take the 0.0042 with the value for x. This is how I do the 5% rule. And I'm going to divide by my initial amount. This is the percent dissociation. So take 0.0042 divided by 1 times 100. So what I get is 0.42%. So no, look at that. Just think about that number. There's the answer to the problem. 0.42%. Only under 0.5% ionized. Against weak acid, didn't ionize very much at all. So it's the same type of problem, just a different kind of question. Okay, here's B. So it's 0.1 molar acetic acid. Okay, do the same thing. See if you can figure out the percent dissociation. Would you think it's the same? It's actually not going to be the same. So write the equation, do the ice table, solve for x and divide it by 0.1. See if we can finish it, go all the way to the end. Again, this X I'm going to ignore because it's the value for X will be so small we can ignore it. I get 0.0013 for the value for X. Okay, and then for the percent dissociation, so for the percent dissociation, 0.0013 divided by 0.100, so my initial amount multiplied by 100. I get 1.3%. We okay on that, the math there and how that all works? So what can we say then? The more dilute it gets, what happens to percent dissociation? It dissociates a little bit more, right? Okay, so this kind of reviews that. So more concentrated versus more dilute. So of course, the acid concentration, the more concentrated, it's higher. But the percent dissociation increases the more dilute it is. The more dilute a weak acid is, the higher its percent dissociation. And actually this last statement, dilute weak acids require the quadratic equation. And I'm just going to be honest with you. I'm never going to give you the quadratic equation. You'll have to use it, which means we'll always be ignoring X. And the AP test, I think, will be the same way. I'm sure it will be. Which is good news.
So why don't we just give them, they're like, well,
So that's also the same for, would that be the same for strong acids, or strong acids just fully dissociate?
Strong acid just fully dissociates. So their percent dissociation is going to be really, really high. Matter of fact, it'll be 100% is what it'll be. Okay, so here's another problem that's this percent dissociation thing. Am I going too fast? Polly, am I going too fast? But again, I'm going to do the same process. And to me, and this is why in doing chemistry problems, I don't care if it's regular chem or AP chem, especially in AP chem, to me, we got to write out the equation for what's going on. And then do an ice statement. I'm going to do that here again. This time we're given the percent dissociation. So I've got lactic acid. So again, I'm going to write out the equation. And then I'm going to set up an ice table. And I know that I start with 0.100. I know over here I have 0, 0. But this time we're trying to solve for Ka. We're trying to solve for Ka. So Ka, I know, is going to be equal to H plus times C3H5O7, this lactate ion, over the lactic acid. So I can find these components out, I can plug this in. But here we are told this time the percent ionization, it's 3.7. So what I'm going to do is I'm going to go 0.1, which is what I started with, times 0.037. This is the 3.7%. So I have 0.1 times 0.037 is 0.0037. So this is how much ionized. This is what I started with. This is how much I must have ended up with the H plus. 3.7% is ionized, which means then here it would have been plus 0.0037. So again, note where I got that. Okay, I got the 0.1 and it said it's 3.7%. Well, 0.037 is 3.7% in decimal form. This, because it's 1 to 1, and here I'm going to add is 0.0037 as well. Here I'm going to subtract. Okay, see if you can solve for the K value. So now you can just plug these numbers in. So what I get here is 1.4 times 10 to the negative 4. Not too bad, not too bad. And again, just like I said, it would be probably good. Like tonight, Kara, I'm going to sit down and watch Georgetown and or Gonzaga and Baylor.
You will win.
I think I want Baylor to win.
Yeah.
That game on Saturday was an incredible game. But I would try and just rework these problems we're doing today. Okay, let's now go into the bases. A strong base. And this is why we have to have the list memorized. In first year Chem, again, last year we didn't get to it, other than I guess we got to it if you were following along. But now, in first year Chem, they would always tell you strong acid, strong base, weak acid, weak base. But now they expect us to have those lists memorized. So I'm going to do the same process. And again, the only time in terms of writing the equation, which I'm saying here's step one, writing the equation, the only time I am going to include water is the first problem I'm going to do tomorrow, which will be a weak base. So all the acids and strong bases, I'm not going to include water. So I've got NaOH. Technically, you could have looked at this in terms of writing the equation. You could have included the water with the acids. The one place where you can't include water is with a strong base. The one place you cannot include water, because this is just going to dissociate and give OH. Now, what we're trying to find here is pH. If I can find the OH, I should be able to find the pH. So I've got 0.0500. So again, write the equation ice table. Because it's a strong base, just like with strong acids, what we start with is gone. So really, you don't need an ice table, technically. But I'm just going to be consistent. I'm just always going to use it. And on the AP test, if you use this, they're going to love this. So let me slow down here. I just want to try and get through this problem by the time we leave here, which is in about 1 minute, 2 minutes. So I did an ice table. Because it's a strong base, what I start with is completely gone. And what that tells me now is the OH. The OH is 0.0500. Now the problem is to find the pH. So here we go back to something we talked about last week. So if I know the OH, I can solve for the pOH by doing the negative log of this. So if I do the negative log of 0.0500 to 1.30, that's the pOH. And then the pH is going to be 14 minus 1.30. Gives me 12.70. Does the pH of 12.70 make sense if it's a strong base? And it does, because it's above 7.
Wait, where did you get the 14?
Remember,
Because of the level.
pH plus pOH is equal to 14.
Gotcha.
Hey, good job today, guys. I will see you tomorrow. And we're going to keep cranking and telling good jokes and everything. Tyler,
Thank you.
I hope you get feeling better. How you feeling, Tyler?
I'm feeling all right, you know. Nothing too
Well,
terrible, but
you're doing a good thing to be smart and everything. So, Tyler, that's it. And you think you'll be tomorrow or